Newton's second law, question part 2. Now we will discuss the relation between acceleration and 1 over mass. We drew a line that passes through most of the points that we have assigned on the graph. Even if there are dots outside the line, it's okay. The line is passing through them. As we said, it is a straight line, so if we stretch it, it will pass through the origin, which is 0, 0. Thus, we will calculate the gradient by doing a triangle under the line, just like we did previously. This is how it is going to look like. The length is here, and the scale here for each square is 0.1. So the length is equal to 0.5 meters per second squared. Now for the base. The scale here for each square is 0.1. So the base is equal to 1 kilogram to the power minus 1, because the x-axis is 1 over mass. As we did previously, the equation for the gradient is length over base. So we already have the length and the base. It is 0.5 meters per second squared over 1 kilogram to the power minus 1. The gradient is 0.5 meter per second squared per kilogram. So we got the answer by taking the length and the base that are on the graph and writing the equation. Now for part D, what conclusions can you draw from your graphs? We conclude that acceleration is proportional to the applied force for constant mass. As the force increases, the acceleration increases, and as the force decreases, the acceleration decreases. Also to the reciprocal of mass for a constant force, which is the opposite of mass, so 1 over mass. Thus, if something is moving and we add or remove a load, but the force is constant, however only the load is changing, then the acceleration will be affected inversely. If the load increases, the acceleration decreases, and if the load decreases, the acceleration increases, which means it is inversely proportional to the mass.